A very good morning for all my dear children. Before entering into the subject and the class, I would like to congratulate you for your graduation towards grade 8. Yes, today we are going to see about an interesting topic which will make you to fly in the space. Yes, let us get to the slide. Yes, let us see. The first thing, let me show you something. Please look at this ball. Yes, it's a very nice ball. And if you need to move this ball from one place to another, yeah, you can say that the ball is actually stable or stationary. What we should do to make this ball to attain any motion, or if this ball needs to get move, what we should do? Yes, we should apply something. We should actually do a push or a pull so that the ball will actually move. Yes, what is that? This is the thing we are going to deal with. And let me show you another picture also. Take a look at this door. Consider you are standing outside this door or you are inside this door. Yes, if you want to get inside this door, what you should do? You should apply something to this door. You should pull the door or you should push the door. Yes, this pulling and pushing. What we together call this is topic. Before that, and I will also show you another picture. Yes, just look at this picture. I think so you all like burger. Yes, it is placed in a hydraulic pressing machine. What is this hydraulic press? Yes, it will just apply a large amount of energy towards anything you are placed. So it is placed here. So if you are applying some energy, what is happening to this burger? Let us make a deal here. Just look at this. It is actually crushed. So these are the topics we are going to see. You can see that the first topic, a pushing or pulling, and the second thing, something is applied over a particular thing. What is the thing? That is the force and the pressure. Yes, today we are going to see about this force and pressure. What is force? What is force? What is pressure? In this pressure, that is something very interesting. Yes, that's atmospheric pressure. What is that atmospheric pressure? Does each and every particle in this world exert any pressure? How the pressure is handling us and how we are handling the pressure. This is the topic we are going to see. Let us get into the topic. Yes, first thing, what is force? As you all already know, what is a force? In physical term, force is said to be a simple push or a pull or both. A push or pull. A pushing or a pulling is said to be force. What is this pushing or pulling? Something which is pushed means a force to move an object away from our body. Yes, a push is a force we use to deal with the body to move away from us. Yes, pushing. In case of pulling, yes, which we need towards our body, pulling. For example, pulling a door to get inside. Yes, so it is a push or a pull. You can see in this picture, the lady who is standing here, she is actually, what she is doing? She is pulling this so that she can lift this weight lift. Okay, and let us, while considering this ball, we have to apply a pushing force using our legs or our hand so that the ball is moving away from our body. So this is all about the force. And what is the unit of force? The unit of force is said to be Newton. Newton is said to be the unit of force. And you know that who is Newton? He is a scientist who discovered this force for the first time. And then the symbol for this Newton is capital N. Capital N is the symbol for this Newton. Okay. So let us just revise what we had seen. Yes, what is a force? A force is nothing but a push or pull. How this force plays a major role. How this is related with the pressure. Let us talk about it. Just I'm going to show you another example. Okay, just look at the slide. You are having a box, a heavy box. Let me draw it for you. Yes, you are having a box, and this box is filled with iron scraps. What is iron scrap? Some hard things which is made of iron. Yes, if a box is filled with iron scraps, how you can feel the box? It will be very hard. Yes, hard box. Likewise, 5 boxes, 1 2 3 4 5, 5 boxes are placed on a table. The table consists of a wooden. It is made up of wood and a lightweight wood. Okay, it is a lightweight wood. Yes. So if it is made up of a lightweight wood, what will happen if you are placing the iron scraps on the table on side by side? You can just feel a small bump. Okay, a small bump under the table. Yes, under the table there will be a small bump. Yes, while you are sleeping in your bed, you could feel that your body who is heavy, which is heavy, it will be making some bump in this cot. Yes, just like that. Yes, so we are placing the 5 boxes arranged side by side. The next thing we are going to see is that we are doing the same thing, but we are placing this box one on the another. Okay, you are placing this box one on the another. So what you can feel, you could feel a very deep bump or a very big enlargement in the thing. This is under this box. Yes, you can feel it. Yes, you can see that. Yes, what is this? So what is the difference between this picture and the picture I had showed you here? What's the difference? While placing the box on the side by side, you can have more number of area. Yes, the area here, it covers a larger distance. But yes, you can feel that the more area is covered here, but at the same time, while you are placing the box one on the another, you can see that this area is only covered. On that area, heavy weight is being loaded on a particular area. Yes, this is the thing. So from this we can explain what is pressure. You know that force is a push or a pull. At the same time, what is pressure? Yes, let us see what is pressure. A pressure is nothing but a force applied over a particular area. Okay, a force which is applied over a particular area. Consider the table once again, and we had placed what we placed? Yes, those boxes here. So you can see the area covered is this much. So what we are doing, we are applying some force towards a particular area which is defined as pressure. So for each and everything there is a unit, and for the pressure, the SI unit, the standard unit is what? It is Pascal. Pascal, and the symbol is PA. Okay. So what is Pascal? What is 1 Pascal means? That is when 1 Newton of force applied per square meter. For example, we are applying a force of 1 Newton towards the area of 1 square meter. What is that 1 square meter? This is 1 meter, this is 1 meter. Then you are applying force towards this. So this is said to be Pascal. 1 Pascal is equal to this much. Yes, 1 Newton of force applied towards 1 meter of area. This is the Pascal. The formula for pressure. So as we already told, the force is applied on a particular area. So force by area, which is equal to pressure. Pressure is defined as force per unit area or force given to a particular area. Okay, so this is about the force. Yes, we need to know how this pressure is acting upon different states of matter. We know that there is different state of matter. What are they? Solid, liquid and gas. In case of solid, you could see an iron nail which is used to hang calendars and all. Have you observed that each and every iron nail, the tip will be like this, it will be sharp? Have you observed that? Why the tip is short for an iron nail? Can you say? Yes. For that, let us have an example. I'll show you a picture of an iron nail. This is the picture of the iron nail. And as I told you, the iron nail is sharpened at the edges. It is actually sharp. Why it is sharp? Okay, so what happened when the iron nail is blunt or it is not sharp? Yes, let us have this. We are having a ball and we are having a iron nail here. Okay, and we can see that this is having more area and it is not sharp, and we can see that here this is having a shorter area and it is sharp. While you are applying a force using the hammer, we know that pressure is the force applied to a particular area. This is that area, this is the force, and while you are applying some force, while you are beating that nail, it becomes a pressure given to this ball or given to this nail. Yes. So when it is blunt, it is having more area while you are applying that force to that, and it is not entering into the wall because the pressure you are applying is actually it is distributed throughout the area. But here the complete force you are applying to this nail will actually make this to move inside the wall since the pressure applied is larger. Can you able to find that? So can we see it once again? Yes. What happens when the force is given to a smaller area and a larger area? So for that we need force. A force is necessary and a force is given to a larger area. Here the force is given to the smaller area. What do you mean by smaller area? In case of iron nail, you will be having a sharp edge. So if you are beating that iron nail using a hammer, the force is completely given to a smaller area only. Yes, that is what I am told you here. And if you are given, the pressure exerted will be very small. While comparing with this, here the pressure exerted will be very high, while here the pressure exerted will be very small. This is the thing. Okay, can you able to follow? So only the iron nails are sharpened at the edges. Okay, then in case of solid, you can feel the difference. Why it is hard, why it is very why it is sharp, and why it is blunt. If it is blunt, if you are applying some force, what happens to that? In case of liquid, what will happen? Yes, for that, let us take this glass of water. Yes, it's a very fine glass consisting of pure water. What we are going to do is that we are going to divide this glass into 3 parts. Yes, we can have this as part A. We can have this as part B. We can have this as part C. Okay, and let me tell you an example. We are dividing the weight of the water, okay, into W1, W2, W3 and W4. While considering the whole glass, and let us take this air molecules should always be present, no? And air is also having weight, as you know. Air molecules having weight which is nearly equal to 0, but it has some weight. Each and every atom is having some weight. Okay. So let us take that air also into this consideration. Let us take the weight of the air as A. While considering this whole glass of water, the glass consists of the weight of the air plus the weight of this layer plus the weight of the second layer plus the weight of the third layer and the weight of the fourth layer. Okay. This while we are considering the whole glass. The whole glass is having this much amount of weight. Okay, now let us consider by part. While considering the part, you can see that part C is having the weight of W1, the water, and the weight of air molecules. Okay, part B is having the weight above that and the weight of W1 and the weight of air molecules. Part A is having the weight here, the weight with the part B and weight with the part C and also the air molecules. So, can you able to identify which of these weight is weighing higher, which is having the more weight, which point is bearing the more weight? Yes, surely point A is bearing the more weight since it is having weight 3, weight 2, weight 1 along with this air molecule. Okay, now if you are making a small hole in this glass, what will happen? So I'm gonna make some small hole here. Let us say I'm going to make some small hole in the point C. You can see the water flow as this. So I'm also going to make a hole at the point B. The water flow will be like this, and I'm going to make a hole in the point A. The water flow will be, yes. So why it is happening? How it is happening? You know that the more weight is beared by this point A, so that the hole which we are making in the point A, so that the water is exiting from this point to a maximum extent. So this is what the pressure is exerted. This is how this pressure is exerted. So if you are having a tank, maybe a water tank, you can call it as a water tank. Water is filled in this tank. So if you want to make a pressurized water supply to your home, where you should make the hole? Yes, where you should make the hole? Yes, it is at the bottom. The bottom of the tank will be having the high pressure, so that you should make the hole at the bottom, since it is carrying the all other weight of the water. So this is the thing, so that the tanks are actually, we are fetching the water using the tap from the bottom layer of the tank. Okay, so you can see that this is how this is an experiment for concluding the water pressure, and the pressure is always high at the bottom. And why it is high means, you can see this, it is traveling through a larger area comparing to this and this. Okay, yes. So what is pressure? We can once again identify what is pressure. Pressure is actually a force given to a particular area. Pressure is a force given to a particular area, and from here we have to make a thing, we have to understand a thing. If for anything which is placed in this format, for example, pressure is equal to force divided by area. For this, there is a thing in physics called directly proportional. If something is equal to something, for example, we can't say 1 is equal to 2. We can say that 1 plus 1 is equal to 2. So that if the value on the right hand side increases, similarly the value on the left hand side will also increase. So that if the force is increasing, the pressure will also definitely increase. Okay, if the force we are giving maybe to an iron nail for anything with, if it is increases, it will also increase the pressure. It is a direct concept. Okay, another thing is that we can say this pressure and this area, how it is related means it is inversely proportional. It is written in an inversely proportional manner, so that if the area actually increases, the pressure on that particular area is actually decreased. Okay, and if the pressure is more, we could obviously say the area is very less. For this we can take the example of iron nail and the ball or a box. Okay, let's consider this is a box. The iron nail is having a sharpened edge. Okay, it is having a very sharpened edge, while the box is having a larger area. While you are using a hammer and beating these two, which will get inside the wall? Yes, obviously the iron nail will get inside the wall very easily, because the area is actually small, so that the pressure is actually very high. Okay, this is the concept. Yes, the thing we are going to see next is that, what is that? So from this all the thing, we could say that wherever there is a weight, there will be a pressure. For example, in a glass of water, the weight which is very high at the bottom layer, so that the pressure is also high. So can you just imagine our atmosphere? What is atmosphere? Yes, it is a layer which is consisting of air molecules. My next question is that, does the air molecule bearing a weight or not? Yes, obviously all our air molecule consists of some weight. The next thing we are going to see about this atmospheric pressure. It is a very important concept, atmospheric pressure. Yes, please take a look at here. Here we are having a boy standing here. We are having a boy, and if the boy is standing in air, maybe wind is blowing from this side. Let us consider the boy is having a big cardboard. Okay, he is having a big cardboard and he is trying to run. What he is doing? He is trying to run. Can he able to run very easily? No, he can't, because we are having the air which will be actually pushing him. So air is also giving us some pressure to stop our movement. It is also giving us some pressure. So obviously air is also having some weight. What exactly this atmospheric pressure is that? What is that? It is nothing but the pressure exerted on a body or a surface by the air molecules. The air around us is also giving some pressure on us. This is the atmospheric pressure. Okay, so this is what we are going to deal with. This is a diagram which shows you our earth. This is our earth, and the atmosphere, we know that atmosphere consists of different layers and it is having the air molecules also. Okay, let us consider here, while talking about this atmosphere, it is made up of what? Air molecules. So these are the air molecules. So you could see that if when you are going from the ground to the top, we could find that the air molecule, it is actually decreasing, but at the bottom layer of this atmosphere we could find more air. You know that while people are traveling to hill, where they are actually hill climbers, they used to have an oxygen tank with them, because there the air molecules will be less comparing to the ground level. So only they are carrying that oxygen tank with them. Okay. So we are having this atmosphere. From this atmosphere, we are taking a layer here, this layer alone. Okay, we are taking this layer. We could see that the air molecule here is more in number than the air molecule here. Okay, and obviously you know that our earth is having what? Gravitational force. And what this gravity will do, whatever the thing which comes nearby the earth, it will act like a magnet and try to attract the thing. Yes, the gravity will attract the thing. So if the air molecule is nearby our earth, it will also try to attract this air molecules also towards our ground. So it is also attracting the air molecule, and we could find that there are trillion and billion number of air molecules which together forms a heavy weight. So it is also exerting some pressure on our earth and on us also. Yes, so that is said to be the atmospheric pressure. So what is atmospheric pressure? It is defined as the pressure exerted by the atmosphere on the air and on us. Yes. What magnitude? What is the amount of this pressure? Yes, let's just see here. The atmospheric pressure, which has the value of 101,325 Pascal. So, which is nearly equal to 6.6 kilogram per square inch. That means for each and every inch in our body or in our earth, for example, this is an inch. In each inch we are having nearly 7 kilogram. We are bearing 7 kilogram of weight. For example, you're bearing your school bag, no? Likewise, in each inch of our body, it is exerting that much amount of pressure on us. But how we are surviving? Can you able to feel the atmospheric pressure? No, we are just like birds only. No, we are just, maybe we are standing on the ground, but we didn't feel that as if we are exerting any pressure. What is the reason behind that? What is the reason? Because we have the blood flowing in our body, and that blood, you could heard about the blood pressure. Yes, that blood is having some pressure. That blood pressure is responsible, which is acting opposite to the atmospheric pressure, so that we are not feeling any pressure. Okay, so before that we will talk about that in detail. We are having this pressure. How this pressure can be measured, how this atmospheric pressure can be measured? It can be measured using an instrument called barometer. What is that? Barometer. Using this instrument, it will be like a clock, maybe. Okay, yes, using this instrument we can measure the amount of atmospheric pressure at a particular area. And this is important. Each and every one of us, each and every layer, each and every inch of our earth is bearing a weight nearby 7 kilogram due to this atmospheric pressure. But we can't feel. Why the human can't feel? Why the animals can't feel? Means we are having the blood circulated throughout our body, which is also having the pressure, which acts opposite to that atmospheric pressure, and we are not feeling any pressure exerted on us. Okay. The next thing, so we are telling that we are not bearing any pressure, we are not exerted on any kind of pressure. But have you think about the astronauts? Okay, when you are going beyond the earth, when you are going away from the earth, so if there is earth, we can see, as I already told you, this is the atmosphere. It consists of air molecules which is pulled towards the ground. So obviously from the thing we are seeing using a glass, where the pressure will be at most, it will be at the bottom layer, because the air molecules from all this layer come to a point at this part which we are having the more pressure. So when you are going from above the earth, the pressure will be decreasing. We will be having very less pressure. So the pressure decreases when you are going beyond the earth's surface. When you are going to the top, the pressure will actually decrease. At one point in the space, we will be having zero pressure. There will be no pressure at all. So what will happen? What will happen? If there is no pressure at all, we will be actually, we know that I told you that our earth is, our blood is having some pressure. So if there is more pressure and less pressure, we could see eventually all particle move from a point of higher pressure to a lower pressure. This is the term. All the particles move from the higher pressure to lower pressure. This is the actual phenomena which is happening everywhere. Okay. So before talking about this astronaut, I have to tell you, we can have an example for this. For example, you are having a balloon. Yes, you are having a balloon. Here there is the opening in the balloon. Okay, having a balloon, and this balloon is filled with air, so that no air can enter, because it is in a tight manner. Okay, if you allow this hole to get open, what will happen? You can see that the air molecule present inside this balloon will get out. Okay, will get out. This is what will happen to this, because when you are trying to capture the air molecules inside the balloon, there will be lot of air molecules will be present if you obviously keep on blowing the balloon. So at one point the pressure will be increased, so that it is more than the pressure outside. Okay, so what will happen if you just left the balloon? The air molecules within this balloon will come out of the balloon, and you can see the particles are racing. So what this proves is that the air or any kind of particle will always move from a higher pressure to a lower pressure. So we are talking about the space now. Okay, so what happens if this man is not here with the space suit? What is body is actually having? It is having the blood. Okay, and blood is having some pressure. It is having some pressure. So what this space is having? It is having zero pressure. I told you that particles or any fluid will move from higher pressure to a lower pressure, but here we could see that blood will be at the higher pressure and the environment here will be at the lower pressure. So what happened to this man without the space suit means the blood from his body will start to, for example, considering this as his hand, the body will start to expand. Since our body is consisting of skin which is having an elastic property, the skin will actually expand and the blood will start, it will try to flow from his body to the external environment. So only the astronauts who are going to the space, they are using the space chute. So what this space chute is providing? Obviously it is providing oxygen, and also you can see this layer, the pant, which will be just not like our pant we are using, because it is also providing a pressure, so that our blood can't come outside our body. This is the thing happening in the space. Okay, so as we had seen, the atmospheric pressure. What is the definition for the atmospheric pressure? Atmospheric pressure is the pressure exerted on the surface due to the weight of the air molecules which is present in the atmosphere. It is also exerting some pressure due to our blood pressure. We are not feeling that atmospheric pressure. Okay, so can you deal with this? I think so. It is very easy for you. And before the ending of the class, let us have a faster look. Okay, just so I told you about the force. If a thing is stationary, which is not moving, what we should give to that body to make it move? So it is obviously force. A force is a thing which makes a body to move from a particular place to another place. A force is always necessary. So we had seen about force, and if there is a force is having the capability to exert pressure on a particular area. So that is the pressure. So how this pressure is explained? This is using boxes which is filled with iron scraps. While we are placing the boxes side on side, we could feel there is no bump on the table, the wooden table. But while we are placing one on the another, we could feel the slight thing on this table. Okay, this is an example for the pressure, and I told you the pressure, how it is exerting dependence on the area. The unit of pressure is Pascal, and pressure, the exact definition is the force applied over a particular area. Yes, and we had also seen about the iron pin, why it is sharp at the edges. And we have also seen the pressure in the liquid, how it is exerted using a glass of water. And we had also seen how this area is having an impact on the pressure. If the area is larger, the pressure will be less. If the area is smaller, the pressure will be more. And then about the atmospheric pressure. Atmospheric pressure is nothing. Pressure exerted on a body, pressure exerted on us due to the air molecule present in the atmosphere is said to be atmospheric pressure. Yes, and then we have also seen about why the astronauts are using the space chutes in the space. So let us go to the question. This is your part. You are going to think and answer. Number one, first question: what is the push or a pull on a body that causes it to move? What is that called? What is that? For example, we are having a ball here. I need to move that ball. What we should apply? We should apply either a pushing force or a pulling force. So, force. Second one, why the knives? You can see the knives. Why it is sharper at the edges? Can you able to answer? Yes. Just look at the answer. I think so. You too find out. A knife. Just read the answer. A knife, a sharp knife cut object better due to its very thin edge. Because I told you why. If the knife is very sharp and if you are applying the force over this knife, the force is applied maximum. The pressure will be maximum at the sharp edges. So only a sharp knife will cut better than a blunt knife. Okay, and the answer for the first question: a force should be applied for anything. Force should be applied for anything so that we can cause it to move. So that's for today. we will deal a lot of thing in the class worksheet which will be given to you in the upcoming video. I hope you understand this class very well. Just feel the topic, just study from your, not studying, just learn from your heart. Okay, thank you for this wonderful cooperation from all of you. Thank you very much.